All right, so this is going to be a project on the aviation seat rails. The students are going to be Mitchell, Cody, Brandon. We were teams. So team roles. I don't know if it was necessarily needed, but project manager was going to be Mitchell, facilitator is going to be Cody, and I, the scribe. We had an aim statement that says that we wanted to realign the company's machines, employees, and offices to reduce unnecessary procedures and increase operational efficiency. There's several holes and problems with this organization. All right, so the impact on customer and operational effects. So the impact for the customer, like obviously because they're in the business of making seats, rails for aircraft. So the impact for the customer is providing an efficient and continuous supply of aircraft seat rails that meet customer quality and demand. So the like I said, the company is not very efficient when it comes to producing these seat rails. There's a lot of rework and a lot of back and forth. So the impact on operation will be organizing production that promotes a better process flow while reducing the amount of waste created in the current state. So that's just saying that the way that we're going to move things around and the way that we're going to achieve these is going to create a better flow for the operation. So the five lean principles obviously is going to be define value, which is understanding what the customer wants and what the best way to deliver it is. This can be accomplished by analytics, surveys, demographic info, or by simply taking the time to see what they find value in or distracting. Establish how the customers utilize a product or service to do their job or accomplish a mission. The customer wants the best quality seat rails at the best possible price. So that's what we're trying to produce. That is our value. We are trying to figure out how the seat rails can be created better and more efficiently to provide them when needed. Then obviously you get your map of value stream. So identifying activities that contribute to the customer value and what activities are considered waste. So we'll get into that in a little bit, but as non-value added but necessary, non-value necessary processes developed to mitigate its curve. So the next step we're going to move on to is create flow. So ensuring the waste. So creating flow, ensuring that waste has been removed from the remaining steps are value adding. Value creating steps occur here to ensure smooth running flow towards customers. Questions like what tools do we need, how often do they need to be used, and for what job each tool needs. Moving machines and offices around create better flow to reduce movement and transportation. So that's what we're trying to eliminate with this, trying to move some offices, machinery, people around to where it creates a better flow and we're not losing as much time. And then obviously we had to, after you create flow, you got to establish your pool. So with improved flow, time for the customer, time to customer can be dramatically improved, making it much easier to deliver products as needed. As a result, products don't need to be built in advance or material stockpiled. Ask the questions how we can make our approach meet the needs of the customers exactly when they need it. So then after we do that, after all that is said, it's time for pursue perfection. So the way I believe we all look at this is pursue perfection is about the continuous improvement process. So we might be able to iron out some wrinkles in this, but it doesn't mean we should stop there. We should keep on moving to further improve the process. So, small steps turn into much larger. All right, so there's our 5 lean principles. So using lean to improve quality. So we'll be able to do this. So our cycle time or takt times, all that time should be reduced. If with the current proposal, I guess you'd say. So our cycle time could be reduced by implementing Pokeyokis, and we'll talk a little bit more on that. And then takt time, determine how many products must be made per minute to achieve customer demand. And then also employee skills development, train employees on how to handle small problems, give ownership, and then plant floor out change. So that's what we're going to do. And it goes into several more things after this, is like how we're going to talk about it. But So cycle time can be reduced by implementing Pokeokis. An automated system can be added for the first steps of the process. The operator at the hard metal planer machine could send an electronic message to the raw material section in the tool crib. That electronic message could state that the tools and materials need to be delivered to the hard metal planer machine section. This could eliminate the process of checking the paperwork and walking to the different section for parts and tools. The team at Kettle Globing encourages organizations to identify how products must be made per customer demand. The organization needs to make 200 parts per week with 3-hour shifts and 200 parts needed per week. 8 hours times 6 equals 480 minutes of work time, 60 minutes per day for breaks. Total work time per day is 480 minus 60 equals 420 minutes. Total amount of parts needed per week, 200 divided by 5 equals 40. So 40 need to be made per day. 40 parts, 3 shifts equals 13.33 parts needed to be made per shift. So they're doing more right now when they could be doing less if it was a more efficient system. Needed to make the 8-hour shifts. That means we need to make one more part every 31 and a half minutes. So one part needs to be made every 31 and a half minutes. We can use the takt time to measure how well the production is going. If we're able to produce one part every 31 and a half minutes, if the takt time is not being met, then we can use the VSN to determine where the waste is and eliminate it. And then so moving on to the next, employees should be encouraged and trained on how to handle the small problems that will arise. This will give the employees some ownership over a process in turn that employees will take to contribute more. Incorporating the entire workforce to solve problems will help each member learn about their coworkers' jobs and struggles. This can help solve problems easier, like how to meet the new customer demand of 225 units per week. Changing the plant floor layout allows for less time of parts movement. This will lower the cycle time and increase the takt time for the batches of parts being made. The next 2 slides show the before and after proposal of the new floor. So all that is saying that realistically, they can produce less if they were doing better to actually do more. All right, so here's the current plan. This is how it all is. So you have up here your hard metal planer, your 5-axis is way over here. Well, it goes hard metal planer, your 3-axis, and then up to your 5-axis. Well, 3-axis to QA, and then QA to 5A or 5-axis, and just it's everywhere. So our proposal was to move it around a little bit to where it created a better flow of how things are being done. So this right here, so we're moving everything around. So we're keeping our raw material storage and our tool crib closer together. And then so the 3-axis, and then for inspection, and then back to the 5-axis if it passed inspection, and then back to quality, that's office, and then to the deburr, finished parts, and then shipping and package. So it just creates a more flow, less wall time. Because I think when I was doing the math earlier, they spend almost an hour and a half a day, not actually doing like physical work, but more or less walking and inspecting and just setting things up. So within this procedure, the plant floor layout contains improvement opportunities. Murray is created with the current layout as members walk from the raw material storage area located at one corner of the room to the hard metal planer, which is located on the opposite corner of the room. From there, the member walks to the tool crib located next to material storage, and then back to the planer before taking the products to the quality office located close to the tool crib and material storage area. By swapping the planer and 5-axis CNC, all first process actions will be accomplished on the west side of the floor. On the east wall, swapping the shipping and packaging area with the inventory would also save time. So we just try to clean it up a little bit, just, nothing crazy, but if you just do all this, then it helps reduce a lot of the amount of time for, walking, movement, transportation. So increase productivity. So right now, the productivity, customer demand is 200 parts per week, 225 actual parts made per day, 15 parts per shift, 3 batches, 5 parts per batch. And then down here, we have the hard metals parts, 10% day rejected. So it's already, it's 90% effective. Your 3-axis is 95% effective. And then your 5-axis is 90% effective, or 90% effective when it rejects 10%. And deburr is fine. So overall overtime rate of 10% from all employees. So there would be less overtime and more production if the stuff was being, if the CNC machines were more effective and less faulty. So future productivity, customer demand, 200 parts per week, 200 actual parts made per week, 14 parts per shift, 5 batches, 3 parts per batch. Last batch will have 2 parts. Quality. So this increased quality through reducing the number of products that do not meet standard by improving machines and employing training. So this is where it was also added that maybe, well, we'll just move to the next slide because this is, we'll talk about this. So through our resources, so employees, so if we can, and that has training person, training aid. So maybe if we, I was reading about it, that if lean stands for anything, it stands for employee involvement. And that is why the first resource is going to be employees promoting a lean culture, which will allow for employee input to help eliminate waste and find processes to improve the organization. So that's what we want employees. So we need to, first of all, incorporate a lean environment for our employees to help identify areas that can be improved. And then the next thing that was stated was training aids or specialized trainers to come in and teach employees how to better operate, inspect, and maintain machines. This will help lower defective seat rails and reduce work. And it was just a little bit of reading says that, you know, just having people come in and showing these general basics and upkeep of some of these machines that could potentially raise the effectiveness of the machines and bring it up from 90%, you know, to 95 to reduce rework, because that's what's happening a lot. We're spending a lot of time for, well, I mean, for every rail that comes in, for every 10 rails, one fails. So, you know, if it takes 31 minutes to do one rail, then you just lost 31 minutes of work doing that rail because of machinery. And that's where I also looked into the CNC machines. They run pretty heavily on software. So maybe it's time for the organization to upgrade their software for their CNC machines, because if it's something as easy as that, then we can increase the effectiveness of the machines and, you know, spend less time doing the rework and stuff. So in conclusion, we just want to, we went over the floor plan layout, and that is essentially what is going to help fix the process. Thank you.